Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream, a stream where we sometimes make games and sometimes make weird TV stuff. I'm Richard at Richard on the MakeCode Forum.
I'm Joey at J1 on the MakeCode Forum.
And I'm Thomas at Sparks on the MakeCode Forum.
And today, as you might have guessed from the way I introduced that, we're going to be working on the weird TV stuff. So we've been working on this thing that we're calling MakeCode TV. And the idea is this is just a bunch of TV channels that you can switch between. And they're all, everything that you do on it is like synchronized. So like I can change channel right now by pressing A. So you can see we have this news thing just looping. Then over here, we have this skeleton just walking around the screen. This is just test one. We can go back to the news, go back to the, okay, looks like the skeleton had finished. And we went on to the dog and duck show. Back over here. There you go. Skelly's moving again. So it like, you can see it keeps the state in between the channel switches. Which is nice. And so we're going to be, today we're going to be working on one of these channels, which is going to be this news one. So we did the news intro, we got the desk, we got the background, coffee, and I drew some anchors. I wanted these anchors to look real basic, like just like real generic. So drew them like this. And we're going to have them be delivering a news story. And the idea is that we can also make them like, you know, hand it over to Chet with the weather or you know, Allison with live on the scene or stuff like that. We'll have like an over the shoulder graphic for whatever news story they're talking about, stuff like that. So the main order of business today is going to be figuring out how we want to do dialogue and everything. So we want to put these sprites in the right place. We want to make their mouths move when text is being printed out, and we want the text to print out inside some sort of word bubble looking thing. But while I'm doing that coding stuff, I would like us to also brainstorm what silly news stories could we possibly have them do. By the way, you might have noticed I also have them putting their hands up to the ear like they're getting a special bulletin. This just in. So
I have an important question here. Are we, is this when we finally commit to Animal Crossing style voicing for the dialogue?
We don't have a way to do that, Joey. I would love to, but
is it not possible with the sound engine? Like I have no idea. Like
I mean,
because I thought it was
it's possible in that everything is just sound waves at different frequencies, but
making them like making the alphabet into the sound waves is hard. I understand that.
Yeah, it's
yeah.
You can do it with formants, basically, like a formant table, and you can look up vowels and stuff. But it's that's a whole stream. We could do that for stream today if you want. It's kind of fun. You guys want to do that?
I have no idea what you're talking about. So
I don't know what the word formants mean. I would be looking up different types of mints. So I would be interested in doing that because I've wanted that for a long while and it'd be cute. But
okay, well, we'll see how well this comes out. But I'm going to look up formant table. Okay. So, how was speech synthesis done back in the day? Okay. The way they did it was by using these things called formant filters. And the idea was that you have sound coming through that's a bunch of different frequencies, right? All sounds are made up of a bunch of different frequencies. By filtering out specific bands of those frequencies, you can generate sounds that sound like different words. So that's what makes sense.
Animal Crossing use this? I thought they just kind of went.
Well, they use very basic speech synthesis.
Oh, interesting.
Yeah. It's
like just the letter, and they make the noise associated with the letter, is what I recall at least. But I'm bad at it.
Something like that. What we are looking at right here is a formant table. Okay, so here we have 5 frequencies. And these are the different sounds we are making. So this is making an ah sound, or it might be making an a sound. I'm not actually sure which. Probably ah. And you can see that the ah sound consists of frequencies of 800 hertz, 1150 hertz, 2900 hertz, 3900 hertz, 4950 hertz. And then these are the relative volumes of all of them. So we want the 800 to be the loudest, this one to be quieter, this one to be way quieter, you know, somewhere in the middle, really quiet. And then down here we have bandwidth. So typically formant synthesis is done using what are called bandwidth filters. All right. Mm-hmm. So if we look at, let me see if we can find a good graph for this. So when we talk about sounds being made out of frequencies, we can graph all of our sounds as basically amplitude by frequency and then do basically a bar chart, right? Which will show us how much of that each frequency is in the final sound. So a bandwidth filter basically filters those sounds and attenuates them based off of whatever the frequency is, right? So a bandwidth filter has a center frequency, and then it has a bandwidth, which is how much it goes in each direction for this attenuating curve. Does that make sense?
I think so. So does it cut off the things below it, or am I misunderstanding fundamentally?
Yes. Everything below the line is going to be filtered or at least attenuated to that line, basically.
Okay. Makes sense.
And these are sometimes called band pass filters. So here's like the three most common types of filters are low pass, high pass, and band pass. What we're talking about here today are band pass filters, which is just what's used for formant stuff. Now, do we have the ability to do band pass filters in Arcade? No.
I'm guessing no, because
we do not
have that. Okay.
So what we're going to be doing instead is we're just going to be generating these frequencies at these relative volumes. And we're going to see how recognizable this ends up being as the sounds. It's possible it's just not going to work because the bandwidth is really important. If that's the case, we could consider stacking more frequencies at the different frequency bands around these center frequencies. But all right, so anyway, we're going to go ahead and we're going to take this table and we're going to basically put it into a format where we can I just realized the description of the stream is going to be super wrong now. Can someone try to change the description of the stream? Do you guys have that power?
I do.
So we're going to switch over to JavaScript for this just because it's a little bit easier. We're going to go over to our formant table and we're going to copy all of this. I don't know how this is going to paste. Let's see what happens. Okay, so that's not useful. So let's just, you know, do this.
Okay. Trying to synthesize voices in MakeCode Arcade, that an okay description?
Yeah. All right. So we're going to go ahead and do a yeah, so the YouTube one's still going to be wrong. I guess I can see if I can do it real quick. Edit. Trying to synthesize voices in MakeCode Arcade.
Yay.
Learn about formant synthesis. Hooray! All right, we'll see if that worked. Ooh, doing that made your secret comment appear for some reason, Thomas.
Oh, wow.
Yeah, okay. All right, so we want to basically take this data. We're just going to take the different, all of the different vowel sounds, right? So A, E, I, O, U. And these are all at different frequencies, right? So we have from countertenor, you know, up to soprano. And so we're just going to take tenor probably because that's just a nice middle one. And we're going to copy down all of these values. So to do that, let's just go ahead and do class frequency table. And we're going to do another class actually, you know what? I guess we only need one. And what we want to have basically is frequency table entry. And this is going to be a constructor. It's going to take in three things, which are going to be the frequency in hertz, the amplitude in dB, and the bandwidth in hertz. What, are you guys hearing a beat in the background?
Yeah, I was just about to ask as well. Just like a,
It's
like is your mic wobbling or something?
Maybe. Like what? Can you describe the sound?
It's like a
yeah.
It's the best
For
I
a
can
second,
do.
I thought it was like a YouTube tab with the audio on it.
All right. Well,
I think it went away.
I moved my mic, so hopefully
Yeah,
it's not
it
in
went
that
away,
position
so I
anymore.
think you're
All right.
good shape now.
Okay. So I'm just going to go ahead and make a function for making this. We're going to call this tab, and this is going to take in the three values. And return new frequency table entry of freq amp bandwidth. Cool. All right. So we're going to go ahead and say A equals, and it's going to be an array of frequency table entries. So we're going to do tab, and the first one is 650, 080. Add a comma at the end there. Okay, next one, 1080. -6, 90. Next one, 2650. -7, 120. Actually, could one of you guys read these to me?
2650, so 2900.
Yeah.
-8, 130, and then 3250, -22, 140.
Great. All right, let's do one more.
Okay.
So this is going to be E.
So down to E. Okay. A E. Oh wait, it's right down to.
Yeah,
400,
Mhm.
0, 70.
All right.
1700, -14, 80. 2600, -12, 100. 3200, -14, 120. 3580, -20, 120.
Cool. All right. So let's just start with A and A, or whatever these are going to end up being. They might be A and E. I can't remember. And we're going to try to play these. So let's go ahead and do a function, which is going to take in, we're going to do play formant. It's going to take in an array of these frequency table entries. And we are going to play these sounds all simultaneously, basically. So let's start by just playing all of the frequencies at the same time. By the way, these numbers right here are in decibels. Decibels are like a negative logarithmic unit.
Yeah.
0 is typically used for full volume. And then as these get lower, it gets quieter. But I think it's like a logarithmic scale.
Mm-hmm.
I don't know how to convert this to our values. So we're just going to map it however best we can. And hopefully it will, be good enough.
Mm-hmm.
All right. So we need to create instructions for each of these. So we're going to have one instruction for each of these sounds, right? These are going to be sound instructions. And so we're going to do for const entry of formant. We're going to do buffer equals control.create buffer. And I think the size is 12. And then we're going to do music.add note is going to take in our buffer. It's going to take in the offset, which is 0. It's going to take in the number of milliseconds we want it to play for. Let's do a second. Going to take in the beginning frequency, or wait, this is the beginning volume. So we'll set that to be 1024. The end volume, which we will set to be 0. The sound wave, which we're just going to make them be a sine wave right now. Geometry GD says MakeCode Hatsune Miku. See, except sometimes you can see it. Yeah. We are basically making MakeCode Hatsune Miku right now, except not for copyright purposes. Okay, for sound wave, we're going to pass in sound wave 0, which is sine. I don't actually remember. And then we're going to do the frequency. For the volume, we want to pass in. Wait. Okay, wait. I put in beginning and end before. Oh, right. This is the overall volume. So for that, we're just going to pass in music.volume, and then the end hertz is going to be the same frequency, like that. And then we're going to do music.play instructions 0 buffer. Okay, and let's go ahead and do controller.a.on event controller button event dot pressed.
Sine is 3, according to our docs.
All right, cool. Let's do sine waves. We'll experiment with different ones, but oh man, which of these was which? Was it this one? Yes, it was this one. 3. All right, so we're gonna play the A formant. See what we get. That was loud.
Okay, it was loud. I can vaguely hear, like, I could see how the band pass would help on that, I think.
Okay, should we? I guess I'll change the volume. Set the volume to be like 10. Okay, you can hear it a bit. Listen for ah.
Oh yeah.
And we're not even messing with the volume yet. So we're going to mess with the volume for all of these guys. So we have this 1024 parameter, which we're going to change. Yeah, sorry, Anonymous Jedi. Okay, if it makes you feel better, I'm wearing headphones that are directly connected to the computer, so I think it was even louder for me.
Yeah. Are you trying to beat random music? Oh, is there random user trying to do this as well? Wait, I just wanted Animal Crossing voices for our TV show.
Yeah. Okay, so we need to set the relative volume. So what I guess I want to see is there a nice formula for convert decibels to amplitude? Okay, so the amplitude is reference amplitude times 10 to the decibels divided by 20, according to the AI overview.
Okay. And I trust that with my life.
Let's see. Decibels equals 20 times log 10 amplitude. So yeah, that is the right.
Yeah. Okay. Yeah.
Thing. Okay. So we want to go ahead and say const amplitude equals 1024 times math.pow of 10. Oh wait, math.pow, yeah, 10, and then it's going to be entry dot amp divided by 20. And then go ahead and put the amplitude in there. Okay. I think that did help somewhat, actually.
A bit, yeah. Can we play the E real quick just to...
Sure. You can kind of hear it, right?
Yeah, I hear it in there. I wonder if can we make it a little bit faster too, just to.
What? You want it to take less time?
Yeah, like 500, I guess.
Random Uses says, I don't usually join streams, but what is this? Yeah, we're doing formant synthesis.
Yeah. Am I remembering correctly that Random User did have a project that did this?
There have been a few projects on the forum. Random User, if you did do some of this, let us know. But okay, so I'm going to
help us when we make mistakes.
Yeah, sure.
Yeah.
So I'm going to put A is going to be A and B is going to be E.
Unique finale. Right there.
All right.
Oh, okay.
All right. Fun. So let's try a different waveform to get something that has a little bit more harmonics. I'm kind of hoping that will simulate the bandpass effect a little bit. I don't think it will, but maybe it will. So to do that, we're going to take this 3 and we're going to up it. Joey, do you still have the table up?
I only have the table up on your screen.
No, the table for the free waveforms.
Oh. 1 second, I have it in another. Yeah, yes. Which one do you want?
I want square wave 50%.
Square wave 50. That's 15.
Okay, so let's try it with square wave. No, that's way worse. All right. Let's try triangle wave.
Triangle is 1.
I think that's a little bit better.
Mm-hmm.
All right. Sawtooth, I guess, might as well try it. I don't think it's going to sound very good. Is that 0?
Sawtooth is 2.
2.
That makes sense. Tooth, 2, yeah.
Yeah, I didn't think Sawtooth was going to give us anything. Okay, then we can try the random noise too. You can still kind of hear it in there.
Which one's cycle? 16, 32, 64? I don't actually remember those.
Those are like the things we use for like Atari type sounds.
Oh, okay.
So which one is cycle? What are that? Is that like 16?
16 through 18, yeah, for those two. Okay.
Nah. All right, let's go back to sine waves. Okay. So if we wanted to simulate the bandpass filter, then what we could do is we have the bandwidth for each of these. Since we're just generating frequencies, we could generate extra frequencies that go on either side of the band. So basically we would have our normal frequency, then we would do something at like half volume that is down half the bandwidth, and then something at half volume that's up half the bandwidth, and mix all of those together. And that might work. It's going to make a lot of sound simultaneously, but it might make it sound a bit better. So let's try it. We're going to go ahead and do this, and then we're going to do one at half volume. So divide by 2. And then we want to do entry.frequency minus entry.bandwidth divided by 2. Same thing for this other one. And then we want to do same thing, but plus. All right, let's give it a shot. Yeah, so that is much better, right?
Mm-hmm.
Sounds cleaner.
Yeah. So we could just try to do this even more. So we could do for let I equal 0, I is less than, I don't know, let's say 10. This is going to be way too many. No, let's do like 5.
You tried it. Random User tried adding that to theirs, and it got some lag on theirs, they said.
Yeah, it can be tough if you if you're playing like 20 sounds all at the same time. Our synthesizer thing is not really meant for this. unfortunately. All right. So what we would do here is we basically want to take this we want to simulate this band pass that we have, right? And we're going to simulate it in the range from 0 to 5. Okay. So we could do I think we could do maybe a sine wave for this. So we want to grab the first section of the sine wave. So from 0 to pi, which takes us from 0 up to 1 back down to 0, right? So what we're going to do is we're going to say const amplitude equals, we'll call this scaled, equals amplitude times math.sine of I times math.pi divided by 5. And then we're going to add something to this because this is going to be 0 at the ends. And we want it to be here. Let's put this in a variable so we can play around with it. Slices equals 5. Like that. So we're going to make it be math.max of, let's say, 10 and, whatever this is. Okay. So there we go. We're going to go ahead and put that in for our amplitude. And then for the frequency, we are going to be doing, so this is going to be entry.frequency minus entry.bandwidth divided by 2 plus I times entry dot bandwidth divided by however many slices we have. So that'll give us our frequency. And get rid of this. All right, so now we're going to play 5 frequencies for each of these. Not that big a difference, I'll say. Yeah. Let's make this be like, what'd you say?
It kind of sounds the same as when you did this, the 2.
Yeah, let's make it be 10. That sounds better, but it's a very slight improvement.
Mm-hmm.
Right?
Yeah.
In fairness, I'm pretty okay with just like vaguely recognizable as long as we can have something you can smush together in here.
Okay, so we'll just stick with 3 for now. Let's get some more letters in here. So we want I, O, U are the ones we have left to do. So get ready to read the table again.
I got this for you, Richard. I think it's right.
Oh, did you already do it?
Oh.
Oh no, it didn't. It cut off my message. I'll send it to you in Teams.
Or you could share it, do a share link. That works too.
Oh, well, it's a little bit different, I think. You might have to do a little adaptation, but
that's okay.
There you go.
Okay, I don't actually have access to Teams on this computer, so could you do a share link for me?
Share link.
Yeah. This is the fun behind the scenes thing. Yeah. When we do streams, we are doing it on my personal gaming computer because that is the only thing we have that is strong enough to stream and still run things at like full FPS and everything.
Did you put the whole thing into a blob? Nice.
Yeah, I did. Well, I say I did. I was curious to see if the little Copilot in the browser could do it, and it didn't. So I can't take full credit. Arcade is going real slow right now. Gonna say. Unless it's my internet, because it's live stream and everything going on as well.
Running okay for me.
I'll open it up incognito and see.
All right, we're there. And
By the way, if you have access, I want to make it so that people can generate their own sound synthesizers in Arcade. It's tough to do, though. Okay.
I was going to say it's loading okay for me, but then I saw, so let me see. Is this, I can send a message in Teams.
Grab this, put that right
check
there.
On my non-domain join device.
All right, so let's try I and O. You could definitely hear the O.
Yeah, it's more of an E for the I.
Yeah, and I think that, like, if I remember correctly, the way these vowels are actually pronounced are A is ah, E is A, I is E, O is O, and U is right? Like, they're the sounds the vowels make. They're not the vowels themselves.
Yeah.
So I think that's actually... about right. So let's just play a bunch of these in succession. So we're going to go ahead and do all formants equals and do tenor formants dot a eiou. All right, and now we're going to do for const. I don't know. While true. We're just going to pick a random one and play it. So we'll do f equal const f equals rand int from 0 to all formants dot length minus 1, and then we will do play formant f. Sorry, all formants of f. And then we will do pause 500. All right, let's try making this way shorter. So let's do like 100. And we'll make this be 100 as well.
Okay, that actually sounds like good to me, even if it's not recognizable.
This does not sound like the Animal Crossing voices at all, but it sounds pretty cool.
I mean, it's the type of thing that I want. Ooh, not necessarily Animal Crossing, but like a voice, right? Like,
yeah. What does it sound like if you just remove the pause between them and it's just one continuous stream?
That's not going to sound good.
I'm curious.
Horror?
Oh, I see. Because the pause is for while it's playing. I got you now. I understand.
Yeah. Make them overlap.
I thought it was doing like play, pause, play. I do kind of like that.
It's a little too belly is the thing. Like, it sounds like a bell, which I wish it didn't. So maybe we can play around with the... we're going to make this be 200. Let's play around with the frequency again. I mean, the waveform again. So this is sine. Let's try triangle again. Random user says, how many formants are you using for each vowel sound? We're using 5. So you can see the table over here on the right that we're referring to. All right, well. Not doing it. Okay, this is nothing. Yeah, saw waves are useless for this. Mm-hmm. Okay, it was 15 square wave.
That's 50 square wave, yeah.
We can try one of the pulses, I guess. So let's try like 11.
That's 10% square wave.
Yeah. That's not really doing it for me either. Let's try 16.
I feel like this sounds like a voice in a game for a character, right? Like these all kind of do sound like different voices you'd give to different characters in like Undertale or something.
I don't know. They sound too Bell-like still. You know,
that's true.
The thing. Yeah. So typically, when you're doing this,
I was wondering if we could do something with like, can we change the volume as it plays?
Yeah, we can. What do you want to try?
What is it doing it right now? Is it just consistent volume?
So right now it is playing from max volume down to 0. So it starts out. That's why it sounds percussive, because it's starting at max volume, goes down to 0.
Would just doing max to max sound less Bell-like?
We can do that. That might help, but it'll also probably introduce some clipping. So you can hear the clipping now at the end of the sound. Wait, let's change this.
Can we do max at the center of the? Can we do like?
Sorry, what were you saying, Joey?
Is it possible to do like beginning and end are 0 and the center is max? That curve.
Oh, you want to start quiet, get loud, and then go back to quiet?
Yeah, because it seemed like most of the bandpass was in the center-ish area if I was looking at that chart right. But maybe that's just me reading badly.
No, that's different. This is amplitude over time. This is not amplitude of frequency content.
Gotcha.
So what we could do is we could do it as full volume for the majority. Let's change this to be twice as long, and now we'll add 2 notes for this. The second note we'll make much shorter, and we'll make it go from the scale down to 0. So this should hopefully take care of the clipping. Okay, well, it didn't like that. Oh, I put in the offset here. This offset should be 12. There we go. Okay, so no more clipping. That's good. You can't hear the popping at the end anymore. Mm-hmm. So let's go ahead and put waveform over here and change it back to sine for now. So go ahead and do that. Okay. Let's see what we have to do to pitch this up. So I'm guessing that we can't just scale the frequencies together. I'm guessing that doesn't work. But we can try. So let's go ahead and do play formant. We're going to go ahead and pass in a frequency multiplier. And we're just going to multiply our frequencies by this. So do that. We don't want to add to frequencies because the way that humans hear frequencies is an exponential scale. So when you want to go up an octave, for example, that is the same as multiplying the frequency times 2. It's not the same as just adding a set amount in between each octave, right? Mm-hmm. So in order to go up a certain number of octaves, you want to add 2 to the whatever and do it. Random user says, yeah, that's how I pitched mine. Okay, well, we'll give it a shot and see what we do. So let's just go ahead and do math.random in here, which is a number between 0 and 1. All right, we'll do 1 plus that. Seems like it still works for some of the range, but it definitely starts failing at a certain point. Mm-hmm. If I were to do this myself, like seriously, I would take all of these formants in here, I would put them all into a table, and I would interpolate between all of them. All right. Well, I'm not really sure where to go from here. Let's get rid of this. Let's put this pause back down to the thing and. Yeah, still not quite sounding like an Animal Crossing voice.
Yeah, this is very robot-y. I think the bells might have been preferable with the volume just going to 0, but maybe it's just a matter of personal taste. Clearly, we just have to make the news anchors robots, I think.
Yeah.
That's the solution here. Yeah.
I mean, that's a good solution in real life, too.
No, we don't want them to be... Oh, wait. I'm passing in the volume as the waveform. I was like, this doesn't sound like it's having the effect I think it should be having. And no, it was not. All right. You're listening to the soothing sounds of MakeCode 908.3. Playing all the hits from yesterday and today. All right. Okay, what do we want to do with this? I don't
remember it fondly.
All right. So let's talk about how we would Animal Crossing speech is the goal randomizer. We're not trying to do realistic human speech. Though I would love to have like old Junior voice from Mac OS. My favorite text-to-speech voice. You would recognize it, Thomas. But it's if you have a Mac, it is named Junior, and it's the one that sounds like. I'm trying to think. Give me something to say.
Hi, my name is Richard.
Hi, my name is Richard.
Okay.
Oh, that one. I think I do know which one you're talking about, actually.
It has a very distinctive way of speaking, you know, which I like. Random user says my favorite text-to-speech is Sam, which is also a good choice. That's Microsoft Sam. Also fun to do stuff like speak and spell and things like that. Like there's some good emulators of speak and spell synthesis out there, which are kind of interesting. Okay, so if we wanted to make this happen, typically what you want to do is you want to put in a very frequency rich source material that you are passing through these bandwidth filters. So typically you take like noise of some kind, so like white noise. And then you have the bandwidth filter, which is going to filter out everything. By the way, I should specify. White noise is equal content at all of the frequency ranges, just random. All right. So the comparison you often hear for white noise is it sounds like wind passing over your ears, which is just all the frequency is just all really randomly in there. There are other types of noise you can also use. Yeah, sorry, Joey, go ahead.
Oh, I was just saying that's why people use it to fall asleep, is because it's just like a generic. You can't find things to hear in it.
There's also brown noise, which has a lower frequency curve, and that is more akin to if you are outside and underneath like a plastic thing and rain is falling. That's brown noise, which is very, soothing, but it has a lower frequency skew, but it's still random. And then there's pink noise, which is instead of being randomly distributed across the frequency thing, it's randomly distributed throughout the octaves, which gives it a more natural curve that we're used to hearing. So anyway, you would take that noise, you would pass it through a bandpass filter, which would filter out the frequencies. Now, there are some considerations there as well. So we've been talking about these bandpass filters, and the most simple one of those is to just have a straight up, when you're talking about filters, you often talk about curve, So, or slope, I guess is the proper term. So if we look at this, so you can see here we have 2 bandpass filters here. And actually these both have the same slope basically. But the transition from letting all of the frequency through to letting none of the frequency through is not instantaneous, right? We have a sloping period where it slopes down and then goes to 0. And so you can use, with bandwidth, you can have different slopes, which will make it either a more gradual cutoff or a more drastic cutoff, more like what this is. So those are also things that you can tweak. And then once you have all of the vowels, you can start doing consonants, which are kind of harder to do. But formant synthesis is a lot of fun. If you have access to a modular synthesizer, which I'm guessing is I'm speaking to no one but myself right now, you can you know, code it up with your you can make that happen with your various filters and things. It's a lot of fun to do. Since we are still talking about this and we have a little bit of time left, let's talk about vocoders. Everybody likes vocoders, right? Thomas is clapping. Okay, so what is a vocoder? Well, vocoder, often you'll hear people talk about auto-tune and say, kind of make it equivalent to vocoding, but vocoding is actually different. So this is the vocoder I have, the Moog 16-channel vocoder. And vocoding is actually an application of all of this stuff that we've been talking about. So what you can see here is we have a bunch of frequency bands right here. So each of these is referring to a different frequency that is being passed through. And the way a vocoder works is you have a source of sound. That's what's called the carrier, which comes in here. So if we were trying to make speech synthesis, this is where we would put our white noise. Typically, when you're doing a vocoder, though, you will instead, you know, like press a key on a keyboard and have that go through there, not just white noise. Mm-hmm. And then up here, you have the input program. And so this will basically what a vocoder does is it figures out what is the volume in all of these frequency bands for my program. And then it sets the volume to be the same for my carrier. So when we were looking at those frequency tables before, those were giving us 5 formants, which were basically the frequencies that were highest when that particular sound is being made, right? So when I make that ah sound with my mouth, we could choose whichever of these 5 formants are the loudest and set the amplitudes to be whatever we were seeing in that table, and you will get an ah sound coming out at the end. But a vocoder basically lets you do it across all of these bands simultaneously just by taking your voice, figuring out the volume in all of them, and then applying it to whatever comes out. And the end effect is if you put in something that has a specific pitch that comes out, you have created auto-tune, more or less. So I can hold down a high C, and my voice is basically shaping that high C such that it sounds like the words that I'm speaking because the amplitudes are changing, but it still has that like character of the high C that is being held down. So it sounds like my voice has been pitched. Now, if you've ever listened to it, it sounds like you're a robot who has been pitched, which is a cool effect, but it's not exactly the same. When you hear auto-tune, you're more, I think, usually thinking about the vocoder kind of put out to a much higher degree where it sounds like your actual voice is being lifted up by that amount, not just that you are doing this filtering business. But, you know, that's a thing for another day. Anyway, I can talk about sound stuff all day. I think we're done with stream for today. So thank you for tuning in, everybody. The last thing we're going to do here is we need a mini game jam theme for this month. I haven't posted it up on the forum yet. So we've got 5 minutes left or so. Let's pick one. If anyone has any mini game jam ideas that they would like to put into the chat, please do. We also had a thread going on the forum, which I'm going to try and find, where people were submitting a bunch. see, I'm going to search for the word wizardry and see if we can find it. I know it was in the live channel. So we're going to do topics, post, advanced filters, categories, live search. Here we go. All right. So we also have all of these jams that were suggested by folks. So we can read through some of these. Last time we did wizardry. So we're going to read through these again. We have roguelike game jam. So I think we all like roguelikes. The only thing that's a little hard with this one is it's tough to make a roguelike. So kind of hard to do that one. Acid jam. That's a good one, but I kind of wish I want more time to prepare for that one. So since I'm announcing it today, maybe not that. World culture jam, sure. Social media jam. I'm not a social media person, so I don't know. Thomas, I know you. I know no one can take you away from your Twitters and your Instagrams.
This is slander.
And then make a game about Richard streaming. Love that one. Hey, you're always allowed. You are always allowed to put Richard in your games. Let's see, mythological games, but more Lord of the Rings type games, like high fantasy. Then we have RPG or turn-based battle. It's kind of fun. It might be fun to just do like turn-based jam. So you can do whatever you want, but you basically are doing action, 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 right?
Yeah. That could be good. Or even just like, taking turns, jam.
Mm-hmm. Okay, let's see. I think that might be all we have for this one. And shooter game. And then we had some suggestions in the chat. So decisions, combination, monsters, food also may have been done. I don't know if we've done a food jam. And then Woof Woof says sound, and then in parentheses, I will win. Yeah, so if we do a sound one, I will make a game for it, and then I'm not 100% sure you're gonna win there, Woof Woof. I don't like to brag, but I know the MakeCode internals pretty well. Hey, I wonder where do you remember that tape machine I made a long time ago, Joey?
Yeah, I don't have any clue how to find it.
Oh, yeah, here we go.
I guess you did. Perfect.
Yeah, I did this before we had a lot of sound features, so I think I could make the sound much better today. But I don't know if you could tell, it was playing Gymnopedes by Eric Satie. Thomas is like, oh.
I'm gonna have to go listen to that now and compare.
Woof Woof says, I added the play instructions function to my JavaScript extras extension, so anyone could do that now, LOL. Yep. So yeah, I mean, we could do a sound jam. I like that. It's kind of like, I feel like the things that I haven't loved as much about music jam is that when we do music jam, it's like you have to make a song. But with sound jam, it could just be do something fun with sound,
Make a game about someone who makes sound to be special abilities or something.
Yeah. Make a game where you can't see, you can only hear things that get louder and quieter however close you are in like the tile map as you move around.
That would be very difficult to play. I mean, maybe also to make, but definitely to play.
There's a whole category of games that are made that way. Like I once listened to someone play a first-person shooter with no screen. No
screen. Wow.
I mean, this is something that was specifically made for that, but basically it was a combination of text to speech and spatial audio. So it would like if there was something that was important, it would just play as a constant sound that was like in a specific direction, so you could always like seek towards it. And then it also gave very quick text to speech when you like bumped into a wall or something. It would say like touching wall north or something like that really quickly. And you could totally follow it. Like it was interesting. Wolfwolf says we would want dual channel audio. I like how you spelt that because it makes it sound like the different channels are fighting each other. But yes, to do that sort of thing, it would be great to have stereo, which we don't currently have. The way I programmed this, by the way, is I took an actual MIDI performance that someone did and converted it into this. Anyway. Let's see. Wolfa says, please consider volume being the theme. Oh, you don't like how loud this is? You don't like it when I do this? All right. Thanks for tuning in, everybody. I think that's going to be it for us. I think we're going to do a sound one for September, and we're going to have the big game jam in October, so look forward to that. I am Richard at Richard on the MakeCode Forum.
I'm Joey at J Wonder on the MakeCode Forum.
I'm Thomas at Sparks on the MakeCode Forum.
And that's it for us. See you later, everybody.
Bye.